I will give you some definition about it. So before I introduce specifically about the definition, I'd like to, did you have met this case when you like search online and the website will return you this verification? Did you have ever experienced this?
Yes.
Okay. So this basically is like a Google verification, and they want to recognize whether you are a human rather than a computer, because in some cases, like a hacker will use multiple computers to attack this website. So that is why they want to recognize whether you are a human. But in the case, how they decide whether you are a human is by using those images are taken from the satellite. And they just randomly segment those pictures into the several pieces. And then you can just randomly choose whether, in this case, they ask you to select all the traffic lights. So you just need to select them, and the computer will recognize you if you answer it correctly. So behind this case, they are not just want you to be a human to do this recognition. They also want to let you to train those data to collect more data because you are the actual human. So here is my today's outline. Because I forgot this is an 8 minutes presentation, and I present at like 20 minutes, so I will be just introducing in a more simple way. Okay. So I will introduce what is the computer vision and how does this computer vision work, and give you some more clear stance about computer vision by giving you some recent research tasks, and also tell you what the challenges we met in the recent research field, and also give you some real-world application to let you know how the computer vision actually work. So first, we're gonna talk about what is the computer vision. So think like that. When you were a child, and you didn't know what is apple, what is banana, and you didn't recognize what those in this picture, in this left hand. But when you grow up, and your mom tell you, oh, this is an apple, and this is a yellow apple, and this is a red apple, and this is a banana, and you cannot gradually learn all those things. This is you as a human. You can learn it automatically. But the human brain is a very complex system. And even now, scientists didn't know how it works. It's very, very complicated. And so now we want to train the computer to recognize this image, whether there is an apple and whether this is a banana. So the computer, how we train the computer? So first of all, we need a device to capture those images, to collect those data, and pass those images into the computer system, and let the computer to process all this information and generate the output. It sounds easy, but it's actually not very easy. So we are using the deep learning and artificial intelligence, where it stimulates the human brain to teach the computers to see those images and to interpret those images and generate output to like our human. So that you ask a child what is in these images, and it will give you the answer. Well, there's a banana and apples. So we want the computer to do the same thing. Okay. So how does this computer vision work? Like I said before, so first of all we need to collect the data. We collect a bunch of images to train those images into the model algorithms and to process it. So the second step is to process these images. Now the scientists have developed a lot of algorithms to train those images. And in today's lecture, I won't cover it in detail. I will introduce those algorithms in our next lectures. Today it's just a basic introduction. So the final step is to let people understand the images, which is the result generated from the computer. So that means explanation from the model, or to interpret it from this model. So if the model generates the result, but it didn't give a very specific interpretation, that is not so good. We want it like a actual human to interpret the model result. So to give you a more detailed sense about how the computer vision works, here is a specific example. So this is how the image look in our computer. So when you see a human face image, you may think, oh, this is a face. But in the computer, how the data is stored in our computer, we store it in pixels. So you can see from these images, so there are different numbers on each pixels. And 255 means white, and 0 means blank. So those represent the gray level for those images. And also we have several pixels levels, like each images will have different primary colors like red, green, and blue, those 3 layers. So each images have those 3 layers pixels. So this is not a 2-dimensional images. So when we actually input those image data into our lab, into our computer, it will be like 3-dimension image, 3-dimension data, and it have multiple layers, and to store it in a matrices. So now, image recognition problem can be transformed into a matrices problem, a mathematics problem, and we generate a whole bunch of matrices and to input into our computer, and that computer to process those matrices by some algorithms and convolution, and to group those data near the neighbor to generate results by perform a complex calculation on these matrices and formulate the relations with neighboring pixel elements. So after I introduce how the computer vision works, I would like to introduce several research tasks that computer vision mostly deal with. So the first one is classification problem. So we can know that from this picture, there's a cat. And in the last case, we know that is a banana or apple. So the classification problem is fairly simple compared with the other problem, because in this case, you just like the face recognition problem, you input the entire image into your algorithm, and let the computer process it. You will just give the label whether this is a cat or not, and the computer will output this result. But for the other 2 tasks, detection and segmentation, you need to localize those information by giving, like in detection problem, you need to give it a bounding box. By using the bounding box for each cats and dogs in this detection problem, and you will know where it is with the population of each bounding box and the class of each bounding box. And another problem is even more complex about segmentation. In this case, you won't assign the bounding box to each object. You will let the algorithm automatically divide their edge for each object, for each cat and for each dog. They also have multiple objects. So in those 2 cases, you won't just input the entire images. You also have several classes for each object to deal with, to let the algorithm deal with. It's even more complex. So here is the first case, image classification. I use a pathology case. So here is a human cell sample, which the pathology in the real world, the pathology will say whether the cell is benign or malignant to decide whether this patient has a cancer. So this, by giving a group of images, the task is to classify them into a set of predefined classes using a set of sample images that already have been classified. So we ask the pathology to help us to annotate these images, whether this cell is benign or malignant, and to input all those information into the model to train them. And in the real world, the pathology only have 93% of accuracy. Okay, I think I'm running out of time, and I will just go it quickly. But the machine can reach to 95% of the accuracy. So here is an example of image classification. I will just show several other cases about our research tasks. So here is object detection. So think about the Tesla. They will recognize each traffic light and a person and even dogs. So you think about the self-driving case. So they can recognize all of them by detect and localize the objects. Here is another case about image segmentation. So we can say we can recognize the eyes, nose, and mouth for a human to determine whether this image is a face. And we also can say that we can, because the Google satellite take all those photos, they may take photos from different directions, and we want to know whether these two images represent the same objects. So we use feature matching in those image segmentation tasks. And here the same is the case in pathology field. So here is another task about image generation. So did you say that anybody think it's a real person or not a real person? A real person, but actually it was generated by our algorithms. So I put the link here. If anybody want to play around, just click it. So here is a website which those people are not exist. So you can just refresh it. It will generate a new non-real person. It's kind of fun. You can just play around with it. It's not a real person actually. So now the challenges in our machine, in our computer vision area is we actually still don't know how the human brain works. We just collect the data and put a lot of data to train it, but not let the computer to learn it itself. It's kind of not the machine learning, it's kind of data learning. So that's a real problem. It's not only for the computer vision task, it's also for all the machine learning tasks. So they all have those problems. So recently the scientists still working on how to let machine to learn it by itself. So here is several real-world applications. I will not introduce very detailed. So here is the self-driving case and the medical image segmentation tasks. So here is kind of key takeaways I want to let you know. So first, the computer vision is to see and interpret the images to simulate like a human using the deep learning and artificial intelligence. So for a general computer vision task, we need to collect the data and process it and generate the result to let human to understand it. And the third is the several computer vision problems we recently research about. It's about image classification and object detection and image segmentation. These three main tasks. And the fourth is several applications such as facial recognition, medical image analysis, and self-driving cars. Remember that pathology case? So I have seen that pathology only have 93% of accuracy, but actually the machine have 95% of accuracy. But keep remember that the machine definitely cannot substitute the pathologists because all the tools we develop today is kind of like assist them by making life easier, make them work easier to help them. So that's all the takeaways I want to let you know today for today's lecture.